Squared, tan squared. There is a formula for each. It's a lot of fractions. Now, the other thing to point out to you, obviously some of these have like the double angle in them, like your 2x there. So I might even be using one of the double angle identities at some point. It's going to be really exciting. All right, we can rewrite any trig expression involving even powers of sine, cosine in terms of the first power of cosine. So that's going to be in the direction. So what does that really mean? You can only have like cosine to the first power. No cos squared, cos cubed, anything like that. And the half angle identities are consequences of these formulas. So here we go. Express sine squared, cos squared in terms of the first power of cosine. So I'm going back. I see my sine squared, cos squared. So we have two of these formulas. I'm going to replace sine squared with the first one here, this 1 minus cos, and I'm going to replace that with for cos squared. So I'm just literally filling those formulas in to start it off with. So here we go. 1 minus, I'm going to put it in parentheses, cos of 2x over 2. And then cos squared is 1 plus cos of 2x over 2. All right, now, obviously we are going to FOIL it out. We can all FOIL, right? Nice thing about the top, the middles cancel, so we're going to have 1, skip, minus cos squared of 2x. And 2 times 2 on the bottom, 4. Now remember the overall goal. We want to rewrite this problem so you just have cosine to the first power. So we got rid of the sine squared. That's kind of a victory. The next problem is this cos of a 2x. We can't have that. So first thing I'm going to do is just a little fraction work. I'm just going to divide each of these over 4. So I'm going to make it 1 over 4. And then I'm going to make this, of course, a coefficient style. I'm going to make it 1/4 cos squared 2x. So the next thing I'm clearly going to be working on, or my problem, is that. I need it to be cos to the first, okay? So here we go. We're going to use, let's back it up, another one of these lovely formulas. Because we have squared, it's going to be good. But, remember on ours, you have cos squared of 2x. That's what I have in my problem. So the 1x in the formula goes to a 2x. So 2x, I have to adjust it and make it go to a 4x. So when I write out my formula, I'm going to make that cos of 4x. Because 1x goes to 2x. 2x would go to 4x. 3x would go to a 6x. You get the pattern. So on and so forth. Okay, so I'm going to leave this 1/4 in the front, the minus 1/4, and then this cos squared. I'm going to switch back to green because I'm using the formula of 2x. We're going to make it 1 plus. We got to switch it to 4x over, of course, 2. Okay, we're looking good. We're looking good. Now, first question. Next question. Do you have it down to just cosine to the first power? Yes, praise the Lord. Okay, so we really did what they are asking us to do. We just have a hot mess of simplification here, okay? We should distribute this 4 through. We should clean up any fraction work that needs to be cleaned up. Okay, all right. 1/4. So 1/4, now this would be really be a half. So I'm going to put this 1/4, 1/2 together and make it 1/8. Of course, right? Common sense. Negative 1/4 times that, it's still distributing, negative 1/4 cos 4x. Looking good. I would say we probably should put that 1/4 and 1/8 together. Those are like terms. So really you've got 2/8 here. What's 2/8 minus 1/8? 1/8. 1/8 minus 1/4 cos 4x. We did it. How do you feel about it?
Not very good.
Okay, so the trick on that one, the key, is this right here in yellow, that 4x. Knowing to adjust from the 1x to a 2x in the formula, So our 2x went to a 4x. If I were to have, let's say, 3x right there, I would have made it 6x. So you had to adjust in your formula. Avery.
Where does the 1/4 come from on the coast?
This 1/4?
The one on the coast.
Oh, sorry, 1/8. I'm sorry, that should be a 1/8. Is that what you had? Because 1/4 times 1/2, 1/8.
No, like, why are there two of them? I thought it was just gonna one.
Hang on. So let me distribute your 1/4 here.
Oh, wait, never mind.
Are you sure?
I think yeah. No,
You
oh, wait,
sure?
no, I got it now.
Okay. Then I'm not going to bore you.
You have to-
I'm not going to bore you. Because you have to distribute it to the over 2. Yeah.
Yeah.
Sorry, my bad. Are we ready for the next?
No, not really.
Write small. Okay, rewrite sine to the 4th as the sum of the first power of cosine. Okay. Well, first thing, I'm going back to the formulas here that you guys, of course, have. And I'm like, well, we have sine to the 4th in our problem. On your formulas, you have sine squared. So the first thing you have to figure out, how can sine squared, how does that relate to sine to the 4th? I can make it sine squared squared. Okay? So the first thing I'm going to do, I'm going to go back to this problem. I'm going to make it sine squared squared. So that's mission 1. Recognize that still gives you your 4th power. Now, of course, this is an identity. Sine squared, I'm just going to fill it right in off the identities there. I'll give you a sec to look at it. I'm going to make it 1 minus cos 2x over 2, but I'm going to have that squared. Just give me a chance to look and write that in. 1 minus cos 2x over 2 squared. Okay, there's the setups. So now, just a little math, I'm going to FOIL. Why wouldn't I FOIL? We'd have to FOIL out the top. So 1 times 1, of course, 1. If you FOIL it out, you end up with 2 of the like terms, of course, in the middle. I'm just FOILing in my head here. Cos, I don't like this. Cos squared. That's going to be a problem. And then 2 squared on the bottom. Okay, so we're kind of getting there, sorta. So the next problem is, of course, this cos squared we're going to have to deal with. But let's try to kind of break up some of this fraction a little bit here, because I really have 1 over 4. 2 over 4 in the middle, I'm going to make that a half. And then I'm going to have 1 over 4 at the end. So I like the 1/4 is whatever. That minus half cos 2x is good because we just have cos to the first power in the middle. Of course, now my next problem is this little lousy squared. So now I'm going to have to go back to our squared formula. But remember, we have 2x, so same thing. In our formula, if 1x converts to a 2x in the formula, well, our 2x, I'm going to have to convert it to a 4x. So I'm going to write out that formula as 1 plus cos of 4x over 2. So here we go. Let's leave our black stuff alone. 1/4 minus 1/2 cos 2x plus 1/4. Okay, so now I'm using the identity. And we replace that 1 plus cos 4x over 2. All right, now we just got to keep simplifying our lives away. So of course I'm going to distribute. I'm going to see if there's any like terms. Let's just take a look and see what we can do here on it. Switch back to black here. All right, let's see what we got. So 1/4 minus 1/2 cos 2x. All that stuff is fine. So remember, I'm going to think about these as 2 separate fractions. So I'm doing 1/4 times 1/2, 1/8. And then 1/4, same thing, 1/2, 1/8. And then, well, we really can't do a whole lot else with this. We don't have a lot of like terms, but we could put that 1/4 and 1/8 together. What's 1/4 plus 1/8? 3/8. So I'm going to rewrite that as a 3/8. And I'm just filling out everything else. just going to take a minute to appreciate how much we love math. Do we love it? I mean, I don't think it's kind of awful. It is time consuming for sure. But really, wouldn't you say more than anything, it's mostly just a lot of fraction work? That's what I feel it is. I'm just distributing and fractions and foiling. I don't think the formulas themselves are that awful. You might disagree. So if you look on the back of your sheet, of course, your last identity sheet, so that's one of the groups we haven't covered yet. Formulas to lower powers. So now we're going to move our way into these. Get ready for these. We have to do product to sum. That's on the yellow sheet, obviously. And then we have to get into this last group, sum to product. I feel the excitement happening. I feel it building. Not really. Okay, so let's take a look here as we move along, moving along here. So we did this crazy shenanigans. Now we're getting into these sum to product formulas. I feel like, am I missing? All right, so let's talk about the product to sum formulas. Now, just be grateful you do not have to have these memorized. Now, all of these identities hinge off each other. You can make them from each other. Like all those Pythagorean identities, those 6 Pythagoreans, you could make off one identity. All of the double angles, I can make off that Pythagorean. I mean, I can do a lot of stuff here. So I'm not going to get crazy and show you or quote-unquote prove all of these identities to you, but I am going to prove this one to you. So it's possible to write the product, sine u cos v, is a sum of trig functions. To do those, these are going to hinge off those sum and difference identities. So this is on, there's so many identity sheets, I'm aware. This is on those first set of identity sheets that I gave you. So if you look on the first yellow sheet, it's on the back side. So sine of a sum, sine of a difference. On your sheets, of course, instead of u and v, that has a and b. Big deal. Okay. So just to kind of show you how you can make these upcoming identities. So it says add the left sides together. Okay, seems weird, but I'm going to do it. Clearly those are my left sides. I mean, they're not like terms, u plus, u minus, so I'm really just writing it down. Sine of u plus v plus sine minus v. And then, of course, it also says to add the right sides together. Okay, all right, well, my right sides are all of that shenanigans. Really excited about adding that up. So sine u cos v plus cos u sine v. Now I'm doing the bottom ones. I'm going to run out of room. I can already feel it. I'm going to stand underneath. Sine u cos v plus cos u sine v. Well, that looks pretty funzo, okay? Not really. But I'm looking at the right side. I'm like, well, there are some like terms over there. If we take a look at our cos u, cos, these are going to cancel. So that's something at least. So I'm going to combine our like terms and make it 2. And of course, we have all the stuff on the green side over here still. Let me get that filled in. All right, next up it tells us divide by 2. All right, well, I can divide by 2 to each side. I'm just going to go ahead and fill that in here underneath if we divide by 2. Now, usually if you look at your formulas on your sheet, they're not over 2. They like to write everything, of course, coefficient style. So 1/2 I'm going to put in front. 1/2 in front. And of course the 2's cancel. So what we're proving to you, and like I said, I'm not going to make you do all of them because clearly this takes a lot of time, is how you were getting these upcoming formulas. So we started off with, if you take a look at the right, sine u cos v. Sine u cos v. This formula. We just have our sides flipped, and notice they have the half factored out over here. But who cares, whatever. So they factored this half out of the front. So really all of these, what this is showing you, which is traumatizing you, all of these product to sum formulas hinge from the sum and difference identities. It's just manipulating the identities around, and I'm sure you're very excited about that. I can tell. Now, product. Remember multiplying. There's my dramatic dots in there. And of course you can see sum. Now don't let this be like, oh my gosh, there's subtraction. It says sum, she lied to us. Well, of course, remember, subtraction is plus a negative. So you can have subtraction. All right, let's get into it. Express. Sine of 3x, sine of 5x is a sum of the trig function. So what I'm zeroed in here is that we're multiplying, sine times sine. So I'm looking at my identities here, and I'm like sine times sine, sine times sine, sine, bottom. So I'm looking at using this one. So I'm going to have half cos, I'm going to subtract the angle. So let's start right in here. Half, we're going to have, of course, cos. And we're going to first, of course, I'm looking at my identity, I'm going to subtract the two angles. So we can do that in our head. 3x minus 5x. Got it. Back to my formula, minus cos of the sum of the angles. Well, we can add them in our head. What's 3x plus 5x? We got it, 8x. So next thing I would look at is, of course, I'm going to distribute the half through. And this, I think, we haven't seen it for a while. This is an identity. Cos of negative 2x. Look under your even, odd identities. Anytime I see that negative, I'm like, oh man, identity. So when I pull up your identity sheets here, and I'm going to scroll to the front, even, odd. We'll make a little more, even, odd. Okay, so of course I'm looking cos of negative x equals cos of x. Cos is even. Cos of a negative number equals just plain old cos of that number. So I'm going to replace that with just cos of 2x. So that's for my even odd identity. So you're welcome to leave it like that. To me, I don't know if there's any benefit of distributing the half through. Sometimes you'll see answers that they just run the half through it. Half, I said half and I wrote 4. That's a 2 right there. I don't know if there's any benefits to distributing or not. I'll take either. So I don't think that's too bad. Product to sum, is it? That wasn't too bad. Nobody's loving it. I can sense it. Nobody's loving this? Okay. All right. Good talk, everybody. We're on the last page already. Time's flying by. Is it not? Okay. Product to sum formulas. So just again, I'm not going to get crazy and talk about all of this, how these are developed. But of course, your sum to product, so backwards, we just did product to sum, now you're going sum to product, can also be used by your addition, your sum and difference formulas. So if you do like your product, of course, here, you're going to have the half in there, and it turns into sine x, sine y. And I'm going to flip the slide here a second, show you those formulas. Now, look how crazy some of those formulas are. Thank God you don't have to have these memorized. Could you imagine how awful it would be if you had to memorize that third page of formulas? Just because I think it'd be so easy to mess up like a half or a plus or a minus somewhere. I think it'd just fall right off the rails. So now you're going, of course, sum to product. Now they look crazy. They look super crazy, but remember, x and y represent angles. We can all add angles and divide by 2. We can all subtract angles and divide by 2. So yes, I'm aware the formulas look super duper crazy, but you're really going to be adding and dividing by 2 for the most part. So write sine, okay, sum, I'm zeroed in on that plus. Sine of 7x plus sine of 3x as a product. Now I cannot just add them together. They're not like terms. I can't do something weird and make it sine of 10x, even though that'd be a whole lot easier. So I'm looking at sine plus sine. Sine plus sine. Okay, top formula. Because we have the sum of the sine of 2 angles. So super easy. 2 times the sum. We're going to add up the angles and divide by 2. So I'm going to start writing out my formula. 2 times the sine. We're going to add the angles. You can mental math this. Divide by 2. I probably personally wouldn't even write that out, but that's how I'm going to roll on it. And of course, I'm taking a look back to the formula. Times cos, so I'm on this part, times the cos of the difference. So I like to put the dramatic dot in for the times. You don't have to. Cos. And now I'm going to subtract the angles and divide by 2. So I'm going to write this obviously way prettier for my final answer. So I'm going to have 10x over 2, got it. And then 4x over 2. And that's that. It wasn't so bad. Wasn't so bad. Was it? It wasn't so bad. Okay. I will tell you this. It's the beginning part of the homework, which was back to all that crazy stuff we did, that's the time-consuming part. Just to prepare yourself. Just FYI. Okay, so here we go. Verify the identity. Good stuff. Clearly we're working on the left side. Left is more complicated. So I'm looking at what we've got on the top. I'm going to start with this. So I'm like sine, subtraction. So we've got sum, because remember sum really means adding a negative. So I'm back to looking at these guys. And of course you're going to have these on your yellow sheet. So I'm taking a look. We have sine, but we have subtraction this time. So it's the second one. So I'm going to leave that up for a second, or look on your sheet. So of course it's going to convert into 2 times the cos. Add the angles, divide by 2. I'm going to start writing it, my fraction right here. 2 times the cos. I'm going to add the angles. Remember that's a 1x. 3x plus 1x, of course, 4x. 4x divided by 2. Let's just put it in there. Times the sine. And looking back at my formula, now I'm going to subtract the angles and divide by 2. So 3x minus 1x, 2x over 2, of course. That just comes out nice. So now I'm going to work on the bottom. So I have cos of a sum. So cos of a sum, we're looking at this guy. Do that part in green. So 2 times the cos, we add the angles and divide by 2. 2 times the cos. So I'm going to do 3x plus 1x, 4x over 2. And I'm back to my formula, cos of the difference of the angles over 2. So 3x minus 1x, 2x over 2. Now, it looks messy, but man, I think we're pretty much done, aren't we? Yeah. Bam, bam, and sine over cos. Yes. Got it. There's no way I could have done this on Friday with all the other stuff we did. That's why we split it into 2 days. So just to warn you, just warn sounds bad, I guess. The beginning part of the homework, I'm just going to be super honest with you. I never want to lie to you. Beginning part of the homework is going to be this time-consuming stuff, where you have to use like 2 identities, FOIL an identity, and it's a bunch of shenanigans. Like this. So once you get past the first part of the homework, remember, that isn't too bad to me. This next couple, that's not so bad. It gets easier as it goes. That's what I'm trying to tell you. I don't know.